Yes, good afternoon. Good afternoon to everyone. Hope I am audible. So, today we will see the topics on the modules, instances, and the hierarchical modeling. Okay. Okay. So, in the modern digital systems are too complex to design a single monolithic block. Okay. Writing a single file, single code. Okay. So our hardware description based design uses modularity and hierarchical structure and modularity to break the complex hardware into a uh, manageable, reusable blocks. So we have a complex hardware. So we are trying to bring that into a reusable blocks. Okay. So these are the core concepts which you guys want to understand it. Okay. So what is the meaning of module? In the program itself, we have given the thing called module. We went and given it. Okay. So we have to understand what is that, what is the meaning of instance, hierarchical modeling. These form the foundation of scalable RTL design. Okay. So today our focus on these things. So you will try to understand meaning, and I have an lab exercise. I mean the demo also I have, a practicals also I have. Okay. So where these all used, as usual, on these applications we can use this. Now we will try to understand what is a module. It is a, see, like a stone, like a brick. Okay, it is something like a basic building block. Module is a basic building block in verilog HDL. Okay, so what it tells, what it conveys, the module, what it is going to convey. Okay, it is going to tell. Okay, what are the inputs, what are the outputs, and what are the internal logics, and if there is optional submodules we will go on. If you are going to create a module with the submodules, we can go on to use it. So a module, it is like a fundamental block. So using that block we will build the wall. As like our building our house, we need a brick. Okay, we are going to lay the brick in such a way that, where we will go and able to build the wall. Likewise, module is a basic building block in verilog HTL. Okay, and it conveys, it defines the hardware block. See, whatever the system we are going to develop, that you can define with the help of module. Okay, so think the module as a reusable hardware components, like AND gate is one module, multiplexer is another module, adder is another module. Using the adder, we will go on to use the gate. So these all are example where we can go and reuse it. Okay, so now we will come to the syntax part of the things. Okay, so the first thing you have to, whenever you going to define a hardware, that means you need the module. You need a module keyword. Okay, and then the module name. Okay, module name, that is something like an identifier. It has a same rule. If someone would have learnt about the C language, how the identifier you have to declare it, how the variable you want to go and declare it. It can start with name, but it cannot start with number, but you can use number. Okay, and we cannot use special symbol except underscore. Okay, so these are the things which follows the same way it follows. Okay, then we have to give a open parenthesis, close parenthesis, and then the semicolon. So inside we are going to define the what are the inputs to that hardware and what are the outputs it's going to get. Those ports we will be mentioning inside the module. We are creating a module. That module we have a name. That module as a name. Okay, that module as a name. Okay, and to that module what are the inputs you are going to give and output you are going to give. You can give input a comma b because both are same, so you can give, you can write something like this also, input a comma b instead of these things. Okay, since we have an output, you have to give a comma, output y, then afterwards nothing is there, you don't want to give comma. So these are the basic syntax in declaring the in defining the hardware. Okay, next we want to connect, and what is the logic? You see, no, that internal logics. So this is the logic it went and used, and it is simple. We are assigning it the output y is equal to, we are assigning it, and then whenever the module is started we have to give end module. Okay, so this is the simplest AND gate to to explain about what is the module. Okay, so this is an AND gate module. Okay, using this AND gate you can go and create your 4-bit or 7-bit. Okay, how much ever bit you want, you can go and create it. So now when you tell it is a module, it has some characteristics. Okay, so it want to be reusable, encapsulated functionality, synthesizable hardware block. Simply not only for the simulation only, we need a synthesizable hardware block, and independent verification possibly, supports hierarchy and improves the readability. So these are the characteristics of the modules. Now module ports. What is port? Because in the module we were trying to give input port and the output port. Okay, so the module port, the modules communicate through the ports. How it is communicating? Through the port. So even they will call it as a net. Okay, so it is input, output, and in and out. Okay, three things. That means input will receive the signals. So what we can give is, we can give input clock. So that module you can go and give the clock, and output, it drives the signal out. So output we can give, we want to use this output and we are giving it done. Then in out, it is bidirectional signal. So something like bus, it goes in this way also, it goes in, so it can act as input and output. So that is what in out. Okay, in memory interfaces, tri-state buses, and input output systems, we will go on to use these. So these are the ports, and the type of ports are input, output, and in out. Okay, these things you try to keep in your mind. Okay, now let us have one more example. Okay, so what is our example? No, we have a mux. How we will write, how we will draw the mux? We will draw mux something like this. Okay, and select line. Okay, this is the select line and this is the output, and A and B. Okay, so if the select line is 1, okay, if the select line is 1, the Y gives B. If it is 0, Y gives A. So that is what the thing we are going to design this in the verilog. How I want to create, I want to write a module. Yes, module has been written and I am giving the name to that my multiplexer. So by the name I can understand mux. Okay, mux. Okay, 2. Okay, they are getting the 2 inputs to 1. Okay, 2 is to 1 mux. Okay, so if you give the meaningful name, it will be easy to understand. And that mux, it takes 2 input. So input A comma B you can give, both are having the same, but input A comma input B, we will try to use it like this. And input also, selection also an input. So we are using the select is also an input. Okay, we are making the selection also an input. Then this is an output. We getting the output. Okay, now how do we go on select? Depending on the select line, if the select line is 1, this is true, this B will be assigned to Y. If select line is 0, A will be assigned, and as usual end module. So select line 0, it is wrong. Select line 0 is going to be true. It is going to use this B and A. Okay, that will be the correct. Maybe you guys can test it. Okay, some typographical error I went and used it. Okay, you can go and test how this compiler going to be. But the main agenda of this is, depending on the select line, the mux gives this signal or this signal, so that we are able to do it with our code. Now we were trying to understand about the module. Now instance. Okay, see, I have one module. Okay, you can create many instance from that module. Instance. Okay, you can go and create many instance from that module. So module is a blueprint, and using that blueprint, however the instance you want, actual hardware copy, we are copying it, actual hardware copy. So one AND module defines can create multiple gates. By using one multiplexer, you can create multiple instances. You can go and create multiple instances. Okay, so that is the idea, okay, of the instance. You can create it. Okay, how we are going to create? For example, I have a AND gate is a module. Okay, now how I can instantiate it, and how I will able to make this module to work. Okay, how this module to work. So this is the module name. I want to give the module name and one instant of that module. And then I want to connect. I can connect through position or through by the name. Here we are using the position, I mean through name. So this input port is connected to the in signal of this instance. In2 a signal is connected to the input port B, and Y to this output 1 of this instance. Okay, so likewise you can create one more instance, and these are the signals for that instance, and this is the port from this. So from this we created 2 instances. Through this we went and create the 2 instances with the help of the dot product, I mean dot operator. Okay, so we have a two physical AND gate instance and we can go on test it. So these are the something you have to understand. So it is one time, and using that you can instantiate many copy of the hardware. Okay, that is the idea, that is the thing between the module and the instantiation. So instance naming, each instance needs a unique name. Suppose I have a adder module and I am creating an instance name A1, I cannot create one more A1, A2 and A3. See, like this wise I cannot create, XX I cannot create. It is an invalid. So instance name want to be a unique name. That is what they were telling. Okay. Now I told how the signals are mapped. Okay. So for the adder, you need a signal A, B, carry in, sum and carry out. Carry in and carry out. This is the way we would have given in the module. In this way, in this position, there will be a signal, something like this. So if you are going to create an instance with the help of position, then you have to write the exact positions. In this exact position, what is that? In this exact position, what is the signal you are going to use it? But here, the named mapping, previously what did is a named mapping. Here, if you use dot and this port is mapped to this signal, and the second one you can write C in. It is not like in the position. You can change and write. So this is by position by named mapping, and this is what preferred in the industry. Compared to this is what preferred. So when you try to create an instance, how are you going to connect the module port to the instance signal, instance mapping, either by positional mapping or by name mapping? So always go for this kind of name mapping. So we created an instance and we try to map that instance with the port A, with A signal. This signal you can go and give whatever name you want. You can declare it in another module, and you can go and do and give it. By seeing one example, you guys will be getting a better idea about it. Okay. So now hierarchical modeling. What is this hierarchical modeling? Okay. So we are going to build a complex system by connecting the small modules. That is where hierarchical module comes. Building a larger hardware from a smaller reusable blocks. For example, full adder built from half adder. That is one example. So I need a system. That system is complex, but how I build that complex system is by using a submodule A, B, and C. When I try to connect it, I am getting a system. That is where the hierarchical modeling it comes. Okay. So the benefit is modularity, reuse, easier debugging, and scalability. That is what they were telling about the hierarchical modeling. Now let us have an example. I have a half adder one module. Please try to understand. And from that I am going to create a full adder. So you know about half adder. Digital design already we went and given it. It is having a 2-bit, and then output we get sum and carry A and B. Okay. So this is an half adder. Try to understand. This is an half adder. I am going to use 2 half adder to have combine these things, gives me one full adder. Okay. That is where the example of an hierarchical things. So how I can do, I am creating one more module. Please try to understand it. This is very much important. I am going to create one more module, full adder. Full adder, it is having three inputs. Same thing like that. Okay. A, B, and then carry in, and the output is sum, and then carry out. This we try to create by using two off adder. How are we going to create? Okay, this is what you have to understand. So you will be able to understand about the wire. Okay, these two things you have to understand. Already it is predefined inputs, so you no need with the off adder. But in the full adder, there is a unknown connections. There are some unknown connections, so that we want to take care. Okay, so now, yes, we created a adder, full adder. Okay, but how are we going to map this input with the off adder? Because we are going to create one full adder by using the two off adder. Now the question comes, how are we going to connect these inputs and the output using the off adder? That is the core of this. Okay, so now already you know I can create an instance. I can go and create an instance. So I can create two instances. I can create two instances. See, off adder, off adder, off adder 1 and off adder 2. I am able to create an instance. That is the idea. Okay, no problem. Then in the first half adder, what I am trying to do, this A I am connecting to the half adder of the A. Okay, so I have one half adder. It is having A and B. Okay, and then it is having sum and carry, sum 1 and carry 1. Okay, so this I am mapping it to something like this. Okay, try to understand. Okay, so here, what is this S1? S1, okay, sum 1. It is from the first half adder. I am connecting it to the wire. It is from the sub S1. Now, in the second adder, what I am trying to give now, so this S1, I am connecting it to one more half adder, okay, that is A, and you will have S2. I mean, not S2, you will have a sum. Okay, this is the actual sum, and this is the actual, what we'll call it as an carry 2. Okay, here we have a carry 1. Now, the B port, please try to understand, that is connected to this. Sorry, B port will not, C in will not. So this is the carry out of C1. Actually, it want to go to the C in. Okay. So already we have a C in pin now. Okay. This is the module of that, and we are trying to connect with this C in pin. Okay. Next, the output of the sum. Okay, see, let me open the, 1 second, let me go and open the images of an, then you will get an idea. I think over zoomed. Okay, so you have two off adder, correct? So in between line, this I am trying to give, no? Okay, so for the one half adder I have these things, for other half adder I have these things. Okay, but I want to connect this one, and this one. So this is the C in, and then this is the output from this I am giving it to here, and this is the thing which I am giving it to this output. So I will get sum and the carry. Okay, so let me take the I should have put the diagram over there, but okay, no problem. We will try to understand from by this. Okay. Oh, I put from the beginning. Okay, so this input gate, okay, this off adder is something like this off adder. Okay, I am connecting it, and I am connecting the this sum to my this. There is an intermediate sum one, that is what I created. This is the intermediate sum one that is created, and that sum is connected to here, and then the carry the C1. C1 is the intermediate. Okay, so you are getting an intermediate one more line which we have to go and connect it. Okay, so that is where we connected it to the carry of C1. So that is all the intermediate we went and connected it. Okay, so this is the idea. Next, for the second half adder, this is something an S1 line. This is something like an S1 line that I want to connect it to the A port. The sum one line, I want to connect it to the A port, correct? Because already this S1 we connected to the sum of the first adder. Okay, now I want to connect it to this thing, that is where this. Okay, and then B, this B, okay, I want to give the C in, I want to give the carry in. So this is where the C in input. So I am mapping the half adder B to this B, okay, to this C in. Next, you will get a sum. Okay, this sum is the actual out, and this is the carry you will get, that is connected to the C2. This is where the C2, and we are connecting it to the C2, and this is the actual carry. Okay, so now you will be getting C out, C1 or it with C2, we will be getting the C out, and likewise you can go and get the sum. Also you can go and get by XOR, C in plus XOR, something you can go and give, and you can get an idea. Okay, so this is what about the hierarchical module using the full adder. Now in the multi structure, okay, in the multi-level hierarchical structure, real system use many levels, processors. So control unit is one level, data path we have ALU, register file and shifter, and cache controller and bus interfaces. So each block may contain smaller blocks. Each blocks will have a smaller blocks. Okay, so in the structure or a hierarchical model often uses structural side. Okay, so like AND gate, G1, OR gate, G2, or XOR gate, these all are explicit connections. So in the behavioral model, it will describe the functionality. Data flow, it will describe the Boolean relationship. Structural, it will explicitly, it is a gate module connection, and hierarchical is multi-level module compensation. So benefits of this hierarchical module is we can reuse it and easier verification, better readability, team development, and example is TX, RX, and then verification engineering, and then support large SOC designs. So common mistake, wrong port ordering, that is bad position mapping, and missing connections, floating signals, and duplicate instance name, something like illegal compilation, and circular hierarchical, something like module instantiate itself, something we bad A, B, C, then again we are putting into the A, so it itself it's a thing, and then poor signaling name and confusing debug, X1, X2, X3, and something like you have to give carry stage 1, carry stage 2 by connecting it to the wire. So these are the common bugs we will be using it. So anyhow, we have to go and use reusable modules and clean hierarchical and avoid the giant monolithic RTL code. So these all are some theory related to the things. So under the VLSP is perfect tree, we can go for examples. These things we can go and use in the EDA tools, preserve hierarchical duty synthesis and debugging, and all the things they were trying to do it. So in thing, we are trying to understand the modules and all the steps. Okay. So now we will try to look this concept by today. We will go further inside the things. Okay. The same AND gate only I'm going to do. I'm going to do the same AND gate, but I'm going to synthesize, RTL synthesize, and I'm going to show you the things. Okay. Practical steps. Okay. So now let me open my uh, okay, hope. Okay. So in that, let me go for VLSI projects or somewhere else I can go. Where, okay, I will use this VLSI projects only, and I will create a new folder called module example hierarchical, HEIR ACHAL. Okay, I'm going to create a hierarchical file. Okay, so I'm going to create a design. I want to go on to create a design. Okay, I am going to create a design. Okay, so what is our aim? Our aim is to, okay, our aim is to create an AND gate. Okay, first, okay, let me create a design, and our motto is, okay, my motto is, okay, so you can have a comment, like a C language. Okay, so now let us define a module. First, module definition for what we will get, 2 input AND gate. Whatever the 2 input, 4 input, I already shown you, but let us try to do it with an proper thing. Okay. So now I told already module. Once the module is created, you have to give end module. This is the stuff. Next, I told we want to give the name. So let us give the name in a proper order. Okay, gate, and I will tell 2 input. Okay, this is the module name, and then let me go on the give, okay, input. Okay, input A, and you can give wire also, that is not a problem. Okay, next I have 2 inputs, wire, and since it is a continuous thing, I am going to give as an wire. This wire, reg, all those things, that is a separate thing, but for a time being you try to understand only. Okay, output is going to be, let it be y. We will keep the same thing. Okay, and since I don't have it, I am ending the module over here. Okay, I am ending the module, or else the best practice is this way will be a good. So you will be, for reading it will be good. Okay, so now let me let me write the logic for A and B. So this is a I mean two input. We are getting A and B, and it gives whether the AND operation is proper or not. Okay, this is one module we went and did. Okay, now let me create the second one. Okay, hierarchical modeling. Let me go and do the hierarchical modeling and instantiations. Okay, let me go and give the instantiation. Okay, so now I need to create a module. Once I create a module, I want to end the module. This module I'm going to use AND gate 4 input. AND gate 4 input. Please try to understand. Okay, so AND gate 4 input. Okay, so let my input be input 1. Let me differ it from, because it is a 4 input. Okay, input wire, you can give wire or no need, that is okay, but input wire input 3. Okay, still I told 4 input, so input wire in 4, and then output wire out. And since I'm going to end it, this is, then I don't want any command. So now I created a module. I went and created a module. Okay, something like this. Okay, let me open this so you will get an idea. Okay, so what I am trying to do is I need four input. Okay, so something like that you can go and give it. Okay, something like that you can go and give, or else there are many ways you can design. Okay, you can go and design. Okay, this is one way, giving the input. So now I have a 3 input. Okay, so this is also an 4. Okay, hope you are getting the things. Okay, so somewhere I am trying to create this kind of things through the code. Okay, hope you guys able to get it. Okay, so now I want to use this two input gates to have this 4 input. See, it looks simple, but when you try to go and do the code, no, there comes the problem. Okay, there it comes the problem. So anyhow, from the diagram I come to know that anyhow I need uh, 3 AND gates. Either you can go with this way, or you can go it in this way, and you can create by using 2 AND gates, you can get the 4 input AND gate, or you can go in this way also. So however you want to connect, So these and all, actually this is the output, this is the input that is defined in our 4 gate input, but inside these things are not properly mentioned. So we internally we want to go and mention, and we have to write the logic for us. Okay, hope you guys. So the same thing, this is the input, this is the input, we defined it. Okay, but this is not properly defined. Okay, this is not properly defined, and this is the input, and this we have to correctly map here, and this we have to correctly map here. Okay, so lot of things are there. Okay, so please try to get an idea about it. Okay, so what I'm trying to do now internally I need 2 wires. Okay, internally I need two things to connect. So I will use wire 1, I will go and use wire 1, and I will go and use wire 2. Okay, now I am going to create an instances of 2 input AND gate. Okay, I am going to create a 2 instance of AND gate. So for that I want to use AND underscore gate underscore 2 input. That is the module name of the this 2 input, correct? That is the module name. Now I am going to create an instance. I am going to create an instance. Let it be U1. Okay, I'm going to create an instance. Then I'm going to connect it through the name. Okay, there I given ABY. Okay, there I have given ABY. So A, I am connecting it to in of 1. Okay, comma, dot B, I am connecting to in of 2, comma. Okay, then the output I cannot give directly. So let me connect it to the internal wire 1, which I have already used it. Okay, which I intermediately, I need a temporary thing. Okay, I am going to use something, this kind of connection. I need a temporary point wire 1, and I need a temporary wire 2, so I can connect it to the other instance of the gate. So that is the idea behind it. Okay, once you understand this concept, then rest by using this you can go and create how much ever you want. You can go and use it, and you can go and work on it. Okay, so now what I'm going to do now, 1 3 4 5. Okay, so now I'm going to create an instance, second instance. Okay, so in the second instance, please try to understand. Okay, in the second instance I want to connect the input 3 and input 4, and then wire 2. Okay, wire 2, I went and connected it. Yes, good. Then one more instance I need. Okay, so let me create the name as instance 3. Now AB, I will connect it to wire 1, and I will connect it to wire 2. Okay, and then this is the out I have given. Okay, I hope now you are able to link this is the out, this is what our module. Okay, so this in 1 and in 2, I am trying to connect with the first instance of the 2 AND gate, and this in 3 and in 4, I am trying to connect it with the second instance of the AND gate. That output I am taking it in parallel, where temporarily I went and used this wire continuous variable, and in the third instance I'm going to connect the wire 1 and wire 2, and this out is linked with my 4 gate input value. So now I got an 4 from the 2 input AND gate. I got an good what I will tell 4 input stuff. Okay, Then for this, I want to uh, uh, write and test bench. Okay, so let me go and copy the test bench, testbench.v. Okay, let me go and write the test cases. Okay, so this is the time scale where it starts from 1 nanosecond. So wherever I give $t, no, dollar time, here you can see dollar time, it will give you in nanoseconds. Okay, and you all know that we are, this test bench is a module. Test bench is a module, so we have to give the test bench one name and we have to end it. This is the way we will go and write the test bench. Okay, and then we want to drive the value for that. We will be learning these things in the future session. For a time being, you try to understand. We want to drive the value so that input 1, 2, 3, because we want to test the 4-gate input. So we went and used the 4 input. This is the testing the input. Okay, and this is the output. Okay, now we are instantiating the 4 inputs gate. Okay, and it is device under test or UUT, it is up to us. Okay, now this our in1, in2, in3, in4, in out is connected to this T in, T2, T3, T3. So now I can go and play it with T1, T2, T3 and T4. So I can go and have an work of, I mean, I can able to go and evaluate the 4 input AND gate. Okay, so that is where this part comes. So whenever you have to put the value on test, we have to begin it. Initial, begin. Once we begin, we have to end it. That is where the structure it comes. And these things I will teach you later, because I want to see the wave file by using GTK wave. And to that variables, I want to pass this arguments. And to monitor in the console, it is like a printf statement. These and all not much necessary for you, but this is T in, I can test. So I can test by giving T in 0, 0, 0, 0, and I am giving 10 seconds. And likewise, I can give the test cases and for the 10 nanoseconds waiting, and I can give all the one and doing it and finish, and I'm going to end it up. So this is the a small test, a test bench where I'm going to use it for our AND gate, 4-bit AND gate. Okay, I'm going to use it for our 4-bit AND gate. Okay, something is not okay. Okay, so now the thing is, how do I compile it? How I am going to compile it? Okay, I verilog. Okay, I verilog. I am having a design file and the test bench file. Okay, I have told you already the output. I previously I used to give the simulation out. Now I am giving an extension VVP. Okay, it is telling that high verilog is, it is going to be verilog, I think so. Okay, now I got an file. Now I got an file simp.vv file. Okay, so I want to dump and I want to create. You can see that for all the test cases, for 4 input of 0, output is 0. Any one input is 0, output is 0. All the input are 1 and the output is 1, and it is for this much picoseconds. That means it is going, it is starting it with picoseconds. That means 10 nanoseconds. Okay, so that is the thing, we got it with the simp. Okay, now please, I want to see the RTL simulation. If I want to see the RTL simulation, this is where the new I am teaching it. This is the first time I am giving you explaining about the RTL. How do I see the RTL analysis or something like how I can see the schematic, how I can go on to see the schematic. Okay, so here let me go and use Yosis. Okay, it will go and give the things. In that I want to go and read the verilog file. Read the verilog file, especially the design, and it went and executing the verilog font design and is a AST, and it is telling that you have two modules. One is indicate 2 input and then indicate 4 inputs. Now I want to make this thing as an hierarchical as a top. Okay, I want to make this 4 input gate as the first from the hierarchical structure. Hierarchy. Okay, the top want to be AND gate 4 input. Okay, the top want to be, because we got 2 modules are there and we are telling let this be the top. Okay, so it is trying to do, yes, hierarchical pass. Okay, so now the top module is this and used module is this, analyzing the design hierarchy, and we are getting the stuffs. Okay, now the things come is PROC proc. It will go on the process pass. Okay, convert the process to the netlist, because it want to go on to use and create the AND gate and all such things. It will go and do it. Next, it is asking perform, executing opt expression pass, performing optimizing. It is trying to optimize this 4 and these gates. And then let me try to go and give the opt command also. Okay, opt also Paris. Okay, opt also it passed. Okay, executing the opt pass, performing simple optimizations. So just these are the commands where our tool will go on this go for a optimization. Okay, so these are the things internally it is going and doing the optimization. Now let me try to show, but show it is telling no, you are not able to show the things or something like it is telling. So now let me tell show AND gate 4 input. Okay, I got an, you see that I got an in1, in2, in3, in4 and two AND gate, and then with that a wire connector, and then these things. So this is what it went and given me it. Okay, so I am trying to show this is the RTL schematic which we got it through our Yosis synthesis. Okay, now let me close this. Okay, simply the show is not working. Okay, simply the show is not working. I am telling the FLATTEN, you go and give me a flatten pass. Okay, so now used module and to get, it is trying to, I am going to give the flat command and let me try to show it. You can see that. Okay, you can see that what all things it went and used. You see that. Okay, intermediary and lot of stuffs. Okay, just I'm giving an idea. These things I will give you an better explanation when it comes to that RTL part of our subject. But this is the first time I have used this Yosis tool. Okay, Yosis tool, and we are able to. Okay, so something a good thing. Okay, so in the open source too also, where you can go and get a good, what I will tell, you will be able to get an without spending money, you can go and do the analysis and lot of things. Okay, the only thing is you have to spend time on it. Okay, so I hope you guys able to understand it. Likewise, you try to do it for, you try to take the half adder and full adder, and how the half adder and the full, how they make the full adder through the half adder. You draw the diagram, then accordingly you go and write the code, and you can go on get the things ready. Okay, slowly slowly we will more depth into it. Okay, so I think this will be a starting point of using the yosis tool. Okay, synthesis tool for our rtl stuff, schematic open synthesis suite. Okay, so if I want to exit exit, yeah, yes, exit. Okay, so that is the command to exit from the yosis tool. Okay, so I got the waveform also. If you want to see the waveform that you already know, gtk wave, and you can go and look into it. Okay, so this is what the plan I kept you for you guys for the today's stuff. Okay, still a lot of things are there, but I hope slowly slowly we will touch it, and I will try to at the end of the, before all the classes end, I will try to consolidate and give you a full structure, so you will be able to have a better clarity. Okay, so hope you guys able to understand it. So now if you have any doubt, please let me know. Meanwhile, let me go and download the PDF. Okay, thank you all. See you guys. Bye tomorrow.